Determine if f of x equals x to the fourth plus 14x cubed minus 686x minus 2401 is divisible by g of x equals x minus 7. Use the table of values to write a polynomial for the quotient h of x if possible. Look for a pattern in the quotient for additional factoring so that you can completely factor h of x. Okay, so we have a few things going on here. We want to know if f of x is divisible by g of x. We also want to use the table to find h of x, to find the polynomial for h of x, and see if we can factor it further. And so let's start out by looking at h of x and finding that polynomial. And so notice that x equals 7 is going to be an error or undefined in our function. And so that will be in our domain part of it. And then let's find the finite differences. And before we even do that, let's check our x values. And we do see that delta x here is 1, since 7 minus 6 is 1, 6 minus 5 is 1, and so on. And then here for h of x, then 2,197 minus 1,728 is 469. 1,728 minus 1,331 is 397, and so on. We'll just go ahead and keep subtracting in the same order. So we see that our first difference is not the same, and so let's go ahead and see if our second difference is constant. So 469 minus 397, we get 72. 397 minus 331 is 66, and so on. I'll just go ahead and subtract the rest of these. And we also see that our second differences are different. And so let's find our third differences. So 72 minus 66 is 6. 66 minus 60 is 6. 60 minus 54 is 6. And 54 minus 48 is 6. All right, so we see that it will be a cubic function since our third difference is the same. And so let's go ahead and look at our rules for our cubic. And so first of all, we know that 6a will equal the third difference. And so 6a will equal 6, our third difference. And then solving for a, dividing by 6 on each side, then we see that a equals 6 divided by 6, which is 1. Then we know that 6a plus 2b equals the second difference, and that's between 0 and 1 as x gets bigger. So we have 48 there. And so now substituting in for 6a, we can substitute in 6 as we saw over here, and then plus 2b equals 48. And so minusing 6 on each side, we see that 2b equals 42. And then dividing by 2 on each side, we see that b equals 21. And now for c, we know that a plus b plus c equals the first difference between x equals 0 and x equals 1, so 169. And so then a is 1, b is 21, and then we have the rest of our equation. And so 1 plus 21 is 22, plus c equals 169. Then minusing 22 on each side, then we see that c equals 147. And so lastly, d is our y-intercept. And so when x equals 0, then h of x is 343. And so there's d. So now that we have a, b, c, and d, let's go ahead and put it in our cubic form. And so we would have 1x cubed plus b x squared, so 21x squared, plus cx plus d. And so just glancing back and seeing how we can factor this, looking at our textbook, then we see a few different forms here. So notice that the one that talks about factoring with 4 terms, then we have basically the same form except for one with a plus and one with minus. And since our h of x has all pluses in it, let's go ahead and see if it fits this form with a perfect cube polynomial. And so looking at this, if a is equal to x, so then it would be a cubed, we have an x cubed, a squared, a, x, and no a, no x. So that fits. And then we need to find what b is as well. So we'd have x cubed, and then notice that the middle two terms both have a coefficient of 3. And so we can rewrite 21 as 3 times 7, so that it has that 3 coefficient. And then we can rewrite 147, if we divide that by 3, then we get 49. And then 343, that doesn't have a 3 in front, but we should note here that that is a multiple of 7 because that is equal to 7 cubed. And so now we also can rewrite 49 as 7 squared. And so now we see that it fits perfectly into our polynomial here because if b is equal to 7, then we have no 7 there, but we have a 7, 7 squared, and 7 cubed, just like we have the b squared, and b cubed. And so we can rewrite this as a plus b cubed, and so we can write x plus 7 cubed. And so now we need to know, is f of x divisible by g of x? And so we can go ahead and just figure out, well, what is f of x in factored form? And so we know that h of x is equal to f of x divided by g of x. And we could rewrite that to give us what f of x equals. So if we multiplied by g of x on each side, then we would get g of x times h of x equals f of x. And so using that, then g of x we know is x minus 7, and h of x is x plus 7 cubed equals f of x. And so using that then, since f of x factors to x minus 7 times x plus 7 cubed, if we divide by x minus 7, we do get our h of x, and those are clean factors, and so it is divisible. And note that that's with a restriction that x cannot equal 7, as we saw in the table. And so for the set of x's, x is in the real number set, and x is not equal to 7. And so let's go ahead and summarize our answer. The quotient is h of x equals x cubed plus 21x squared plus 147x plus 343, which can be written as h of x equals x cubed plus 3 times 7 times x squared plus 3 times 49 times x plus 7 cubed equals x plus 7 cubed. Since h of x equals f of x divided by g of x, so f of x equals h of x times g of x equals x plus 7 cubed times x minus 7, with a domain restriction such that the domain of f of x is a set of x's such that x is in the real number set and x is not equal to 7.